Hello everyone, welcome to the channel SRS. This is Sumit Roy and we are studying today digital electronics in that combination circuit, and in that we'll study full subtractor. As we have already studied half subtractor, this is just the extension of the half subtractor. So let us begin. As in half subtractor, we have studied x minus y, that is subtraction between two bits to give us borrow and the difference. Now it is just the extension, that is x minus y minus z. There are 3 bits. So I've already written the possible combinations, that is if n equal to 3, then L is possible number of combinations are 8. So there are 8 possible combinations. And what we are doing here is we are subtracting, that is x minus y minus z, to give us borrow and difference. So if it is 0 minus 0 minus 0, then obviously no borrow is required, no difference is 0, that is no borrow and difference is 0. If 0 minus 1, that is equivalent to 0 minus 1, and that is 1 has to be borrowed. That is if 0 minus 1 is done, 1 has to be borrowed. This is 1 and 1 0, that represents 2, and 1 that represents 1. 2 minus 1 is 1, or here also 1. So this is 1. Similarly, the next part is 0 minus 1 minus 0, that is again 0 minus 1, again 0 minus 1, that is 1 has to be borrowed, and now 1 0, after borrowing it becomes 1 0, 1 0 minus 1 is again 1, so again 1. Next part is, that is 0 minus 1 minus 1, that is 0 minus 1 minus 1, that represents 0 minus of 1 plus 1, that represents 0 minus 1 0, and that represents, that is 1 has to be borrowed, so 1 has to be borrowed. So I'll write here 0 minus 1 0. So if 1 is borrowed, then 1 0 represents 2, this also represents 2, that is 2 minus 2 is 0, that is 0. So after borrowing 1, the difference is 0. Then again if we proceed, that is it will be 1 minus 0 minus 0, that is no borrow is required, difference is 1, so no borrow is required, difference is 1. Again 1 minus 0 minus 1, that is 1 minus 1, that is 0 and 0, no borrow, no difference, the difference is 0. Again this is also the same thing, 1 minus 1 minus 0, that is 1 minus 1, that is 0 and 0, and 0 and 0. And lastly, that is important, that is 1 minus 1 minus 1. That can be written as 1 minus 1 plus 1, that is 1 minus 1 0. Now if it is to be subtracted, that is 1 0 is subtracted, 1 has to be borrowed, so immediately 1 is borrowed. Now 1 1 represents 3, 1 0 represents 2, so 3 minus 2 is 1, or it is in decimal number system, in binary number system also it is 1, so it's 1. So this is the subtraction, and this is the difference, and this is the borrow part associated. So we'll use K-map to reduce it and to get the circuit by the help of logic devices. Then difference is written as it is a 3-bit, so possible 8 combinations, so x, y and z. So what we'll have is 0 0 0 1 1 1 1 0 0 and 1. Now if difference is being done, that is 0 1 2 3 0 1 2 3 4 5 6 7 4 0 1 2 3 0 1 2 3 4 5 6 7. Now if K-map reduction is possible, in this case it is not possible. So what we can do is we can use we cannot reduce it, so we'll have to write it, that is x bar y bar z plus x bar y z bar plus x y bar z bar plus x y z. It can further be reduced. This is the outcome of the K-map usage, and if further laws and theorems are utilized, then I can reduce it up to yz bar plus x yz bar plus yz. If we go further, then it can be seen as this is x, so y exclusive OR with z plus x y exclusive OR with z bar, that is exclusive NOR with z. So D can be written as, now it can be written as x bar, let it be a plus x a bar. So it can be written as x exclusive OR with a, or further it can be written as a is, this part is a, so it can be written as y exclusive OR with z, or it can also be written as y and exclusive OR with z. So this is the part for B. This is D, difference. Similarly for borrow, if we'll do the same thing for borrow, again we'll introduce the K map with x, y and z variables 0, 0, 0, 1, 1, 1 and 1, 0. This will be for borrow 0 and 1. So we'll give the input as 0, 1, 1, 1, that is 0, 1, 1, 1 and 0, 0, 0, 1, 0, 0, 0, 1. So we'll reduce it. Yes, it is reducible. So first this reduction. So I'll write borrow here. For this reduction, 0, x is consistent, that is x bar, and 0, 0, 0, 1 and 1, 1. So out of them, this is yz, yz. So y is not consistent, but z is consistent. So z plus, now I'll reduce this part, that is, this is the part. So again x bar is consistent and 1, 1 and 1, 0, that is 1 is consistent, that is y is consistent, plus this is the part, that is, this is, now y and z, x is not consistent, only y and z is consistent, that is yz. So this is for borrow. So if we write the logical deductions, then x, y, z are inputs, and as the difference is, this is difference and this is, let this be borrow and let this be difference. So borrow is x bar z plus x bar y plus y z, and difference is x exclusive OR with y exclusive OR with z. This is it. Another thing I like you to remember is just D stands for mean terms of 1, 0, this is 0, 1, 2, 3, 4, 5, 6, 7. So it stands for 1, 2, 4, 7. Similarly, borrow stands for mean terms of 1, 2, 3 and 7. 1, 2, 3 and 7. So it will be beneficial if these two are remembered. So this is all about full subtractor. In the next video, we'll study a 4-bit number subtracted from a 4-bit number. So it will be an interesting part because I'll introduce addition and subtraction by the same circuit with the help of 2's complement. That will be an interesting circuit, and till then, from this part it is over. So till then, it's goodbye. Consider subscribing, comment, like, share, and if there is any doubt, just leave it in the comment section. I'll try to answer them. Till then, goodbye. Also press the bell icon, means you'll get the notifications. Thank you.